creating Appium, and so on. Just a second. Let me make sure that show up. Thank you. Um, Uh, the so for the last 10 years, what Jason Huggins has been up to is building robots, and he's mostly been building physical robots, the kind that you see on the screen right now, but also all sorts of mechanical arms and effectors to automate all sorts of real device scenarios. Including hardware automation. So, just a second. Yes, there we go. About myself, real quick. Hello, Milan. My name is Lana Begunova. I'm a quality assurance engineer, a tester, an SDET, you name it. You know, my profession goes by many names. I mostly like to focus on what I do, not on what you call me. But my main area of expertise is web UI automation and my love field of expertise as mobile automation. And at this point, not only software, but hardware as well. On the side, I do some tech blogging. Honored to have been accepted into the Women in Technology group to write on their behalf and publish there. I write a lot about testing, and as I mentioned, web automation, mobile automation, and so on. I'm not going to spend time explaining to you how I got to know Mr. Jason Huggins and how I encountered Tapster Robotics office in general. Um, I will be providing a link and QR code to the entire presentation at the end. And within it, there's also, as you see right now at this current slide, there's a link to a short blog that will, as an extra story, if you have time, you can read up and learn about that. I'm giving you my LinkedIn link in case you share any of my techie nerdy interests, but also some of the personal interests that I've just kind of splashed out there on the slide as a firework. As a tester, as a developer, I like coding, testing. Of course, I read a lot, sometimes technical, mostly sci-fi, just to relax my brain. Asimov is my favorite, so if there are any fans, do connect with me. Yeah, and I do like old school classics, sci-fi from last century, Robert Heinlein, and on and on. Of course, coffee is always there for me. It's the juice I run on as a techie, as a developer at the laptop. I love music. Not necessarily maybe the kind you would expect. I'm like more of an alternative rock person. Bjork, Tool, Maynard Keener, like Tom York, Flea, you name it. I like it a little bit rocky in that area. Um, I like hiking, working out, cooking, and eating my food, of course. So, to just a second, guys. I think there's a lot of things going on in here. Let me just minimize this window again. All right. Next slide is about Mr. Huggins himself. Not to waste any time reintroducing him, but this is the person who doesn't need a firework of emojis to get introduced to most of the people who's done any testing or any automation testing. He creator of Selenium, Appium, founded Taps Robotics. Before that, obviously, many of you know, co-founded Sauce Labs. Also, a little later, I call it like Obamacare savior type of a role that he did. He joined a team of elite engineers, about a dozen of them, at the White House to fix healthcare.gov. I was a user myself at that time. My entire family sort of quote unquote suffered from how not good it was. So thank you, Mr. Huggins, for taking care of that. If you're interested to getting in touch with him directly, the thing that he's working on right now, the Valet, is available. More information about that is available at tapster.io/Valet. And his LinkedIn account is also shown at the bottom in case you want to go ahead and contact him directly. So a little bit of an icebreaker on what Tapster Robotics has been doing for the last decade. They turned 10 years on May 4th. May the 4th be with you, as I always send to the Tapster office every year. And I want to, this will have a little sound, some music. So anyone with headphones and anyone present here, so that you don't get shocked that there is some musical acoustics going with this video. It is from the Tapster YouTube itself. Oh, no sound. Okay, hold on. I think it may be this. Oh no, sounds pressed up. Okay. Well, hold on. Also, let me just. Yeah, it janky. Some gets janky. Hold on, let me try. Nope. We don't really need the music. I was actually trying to save your ears, so this is probably even more convenient. Yes. So by the man himself, basically a bunch of physical robots that Mr. Huggins has been building at Tapster, so that you could even get some context to understanding why robotics are or may be necessary in some real world scenarios, testing on real devices, you know, in addition to pressing all sorts of hard buttons, like a power button, volume up and down, home button. Then you see it's like point of sale type of transactions. You can't really do that. You have to do it either manual or via a robot. You won't be able to automate it with like Selenium Appium Playwright or anything else. So these are beautiful, beautiful creations that were involving by design a lot of mechanical parts from metal, plastic, the end effectors, the actual thing that acts like a finger and touches the touch screen. All of that required a lot of mechanical work. Okay, that's the wrap. And about 2 years ago, Mr. Huggins has moved on to a virtual robot, not a physical robot. So we are sort of a Tapster for testing automation and device provisioning purposes, sort of done with the physical arms and end effectors and all of those heavy gear mechanical parts. And now we are working with virtual robots with the help of a beautiful SBC single board computer Raspberry Pi, which can now pretend to be a fake USB peripheral, such as a mouse, a keyboard, a stylus, and there are a lot of slides coming up ahead, but basically Mr. Huggins made it so that you can treat your real smartphone as a true personal computer with a bunch of software and hardware and whatnot. What you see in front of you is my last slide from the latest presentation 2 months ago that I mentioned at the beginning, when I was presenting how to set up Appium in 30 minutes. The whole, let's say, selling point for introducing Valet at the end of that presentation was that you can spend 30 minutes setting up Appium, but only if you do that all the time and you're really good with it and you already have almost automatic muscle memory. If you don't do that often and you have to even Mr. Huggins himself last time said that he hasn't touched, at some point he had not touched Appium for 2 years, and it took him like about half a day, like 4 hours to get up and running himself. It's not surprising. I heard Simon Stewart recently himself admitting that he hasn't used WebDriver in forever. He doesn't do it at work, but that's like the reality. Even the creators themselves have to remind themselves how to get set up, and it may take up to 4 hours, if not longer. I tried to introduce a half an hour setup version, and Valet now, I'm showing the last slide from that presentation, just to transition into the entirely new area of like diving in and plugging in, no pun intended, into this whole Valet presentation a little more solidly. So you would be able to view that last presentation if you're interested at the link below, but let's move on. What is Valet? As I mentioned, you want to read up more, go to tapster.io/Valet. It's local first mobile automation with real devices. As I mentioned before, not a physical, now a virtual robot with the help of a Raspberry Pi. We can automate those manual tasks that you wouldn't be able to do without either a manual team or this kind of a robot, basically. There is like no middle ground automating it with like Appium or any other mobile automation tool, because you really got to go low level with this. And in short, it's open source, modular, decentralized. Open source relates mostly to the software. Modular touches upon hardware. Decentralized will cover the network. And this will be three main parts of the presentation: software, hardware, and network. Let's see. Let's move on and see. Well, there were a lot of reasons to build Valet. You know, the 99 of them. The the biggest focus is to automate real devices, not emulators or simulators. And at the bottom of that slide, I threw like a comparison table that I put together myself just to show you how many real world hardware, or not even sometimes hardware related scenarios, cannot be automated with virtual devices. And if you want to satisfy your customers and roll out quality software tested on real devices in real scenarios, simulators, emulators will not do. Somewhere around unit testing stage, you can pass by. In prod, you would need some real devices. So any of those who either have worked or are currently working at mobile dev and test labs with a bunch of tablets and smartphones, you may know what I'm talking about. But oops, apologies. So the main reason behind building Valet is I would say that the independence from cloud services. Valet does not necessarily negate those. It either complements the existing cloud services, but you can avoid cloud vendor lock-in with Valet network, so to speak. Pardon, guys, my throat. So it's built for low latency, as shown, high fidelity, mobile testing using AI and hardware. So the hardware part will definitely get to. Myself as I like that part as a geek. AI, woo woo, everyone's excited, right? We've been talking about AI, everyone wants it. Let's see how or what AI runs under the hood of this architecture. And the modularity of the architecture also allows you to run it either solo or in a small team of 2 to 10 people, mobile devs or testers, or scale it up to enterprise level. And either combine with your existing cloud services or not use them at all if you find that that is the more desirable scenario for you. So the beauty about this tool and technology being created by Mr. Jason Huggins is that it's open source. So it's modular, open source, built on Raspberry Pi. Practically everything runs on on Raspberry Pi, and you get to accomplish that using some computer vision, hardware input output, and it's at its core, it's a very scalable, good old school HTTP over JSON APIs infrastructure. Valet is a classy way to drive your phone. Not my code, Mr. Huggins says, but I threw it in there. I will have to reiterate again that by using this technology, you can avoid expensive cloud or lock-in contracts because it offers you pure device level control, local or remote. Okay, some core features that we've got here. Valet supports multiple inputs, camera-based vision, HDMI video, enable full device side button presses in case you need to do hardware automation. And all of this can be triggered remotely or locally using a plain HTTP interface. Whether you need to fake or simulate taps, capture screens, or press any hardware buttons, such as power or volume, you can access all of that programmatically with Valet. Quick architecture overview. Pardon? So I mentioned before that mostly the main thing under the hood is the Raspberry Pi SBC running over HTTP protocol, sending the good old familiar JSON packets back and forth for faking or actually being able to accomplish that simulated tap or click or complex gesture scenario on the device screen. We're using USB gadget protocol. And there are two main models hardware-wise of Valet. One is Valet Vision, which is camera-based, and the other one is Valet Link, HDMI-based. Some good old deterministic AI modules and libraries are used for object detection and text recognition. And as I mentioned before, it's also available either local, you can control it in the local or remote environment. This is a huge and super detailed architecture diagram prepared by Mr. Huggins himself. I won't go into details because I have many more slides coming up. As I said, you'll have the chance to access this presentation a little later and tap the link and take a look at the architecture diagram in detail in your free time. Mostly you may have noticed and heard that most of the sort of AI testing methodologies these days, or AI-based, are all about self-healing locators, like inaccessible DOMs or inaccessible accessibility trees, no pun intended there. So snapshot-based sort of element or text recognition or field recognition has been popular with many firms and offering other custom or enterprise level solutions. All right, the software stack is big. At the core is the Raspberry Pi OS that runs all the Valet software. The languages that are used are Python. The main reason for it is because most of the AI and machine learning libraries are written in Python, and Python has a strong community where it's just very convenient to plug into the like-minded people and share experiences and get debugging going and fix your stuff. So the core server for Valet is written, the client, my bad. The core server has both some JavaScript and Python. The client is written in Python. All of those links will be provided later on. There's also one new fancy word, NIM programming languages. It's sort of like a fast compiled Python. I'll be frank, I've never heard of it before. Mr. Huggins mentioned it. So it's used in the stack for some of the performance critical modules. Now, the actual core libraries that give us the computer vision, object detection, and text recognition features. OpenCV, Tesseract OCR, and then all backed up by the OmniParser pipeline that consists of YOLO, OCR, Florence. And do not get surprised by seeing Appium as part of the software stack. Since Mr. Jason Huggins created Appium himself, it makes it quite logical that Valet would be compatible with it, as well as any other WebDriver based automation tools, including Selenium and others. At the core, as I mentioned, that's the good old HTTP over JSON client server architecture, which is super scalable, very much similar to Appium, Selenium, and other automation tools. Okay, so there are sort of two ways to interact with a device screen with a Valet. You can either run your automation script through a terminal or IDE. In this case, mostly, I think most scripts are written in Python by Mr. Huggins. However, it is sort of interesting in a way that the Valet web server runs on the Raspberry Pi and serves also and can be accessed as a remote desktop. So while most of the existing Valet customers are triggering automation scripts for Valet, there is even a customer who literally uses it as a remote desktop to have his physical mouse at his desktop controlling the smartphone, the physical smartphone device screen that is showing in the remote desktop window on right in front of him. So these are beautiful and tricky things. However, they do work together. And per Mr. Huggins himself, why this all works is that many people don't even understand what these robots do. The distilled down essence, and it's his quote, not my words, I'm not that original, that the distilled down essence of a manual tester is a fingertip and an eyeball. And that's basically what of those physical arms and end effectors were doing in the previous versions of physical robots, tapping the screens. And for the to replace the human eye, he uses camera for computer vision or HDMI. Just to reiterate myself about the HTTP JSON client server architecture. Valet APIs speak the WebDriver, the W3C WebDriver protocol, where command parameters are expressed via HTTP methods, routes, and JSON bodies, and command responses are accordingly returned as JSON. In the little table there, you see some API examples that run under the hood of any Appium Selenium scripts. You wouldn't usually see on the API level, again, anything like driver.click or driver.get. This is what you would observe when you use any favorite API tool of your own, whether it's curl, Postman, Insomnia, and so on. Valet is very well integrated into that infrastructure, so the commands themselves would look very familiar to you if you've ever looked under the hood, which if you've done a couple of years of automation, you must have. So even the inner workings, although this is a lot, are not that scary when you get to know them. Now, the a little bit of the clarification of how the faking and the simulation of the USB peripherals is possible at all. It works with USB HID, or what's officially called a USB gadget protocol. I consider it sort of I append it to the software stack, and with this protocol, all via single USB cable, you can manipulate your physical smartphone and pretend to send any actions with to pretend to be a stylus, keyboard, mouse, you name it. Also, the Ethernet gadget allows you to share or restrict device access, so you have full control over your security. Now, the reason for the slide is to emphasize which part of the before listed stack actually is the one that supports vision and AI capabilities of this technology. We will get the MJPEG live video stream, screenshots, captures in JPEG or PNG format, OpenCV for detecting UI regions, Tesseract for character recognition, text recognition. And if you have really heavy loads running, you can offload those to a remote GPU running machine learning libraries, so you don't have to run it all locally. It's possible, but optional. Let's move on from software to hardware. And as I mentioned before, there are two main models, hardware models. One is Vision, the other one is Link. The main difference is that one has an autofocus camera, the other one doesn't. The other one addresses the video input through the HDMI card. The main difference to distinguish on why you would use one or the other is mainly the let's say the age and model of your phone. Most of the high-end contemporary phones like iPhones, newer Pixels and Samsung phones do not need a physical camera looking down at it just to capture the video of the screen. The newer phones can be plugged in what you see on the right, the Link version, and there are a bunch of cables. We'll cover that in a couple of slides, and a bunch of components there. But basically, the teeny tiny, the smallest in the world HDMI capture card replaces the camera vision feature on that Valet Vision model has built into it. All right, so Valet Vision hardware stack, I'm not going to read into all the text, but we'll cover it on a high level. On the very bottom here, you see the real device, the smartphone device under test that is plugged into the rig. The rig is about the size of a shoebox, and to make sure the clarity of the screen is captured in good resolution, there are actually sort of black plastic walls built around this thing that are not shown here because we won't be able to see the inside of it then. Of course, the main thing that runs it all is the green thing, very recognizable by its green color. Raspberry Pi is the single board computer that I mentioned before, on which the web server is installed. Right underneath it, unfortunately not displayed on the picture, but we can use our imagination and imagine that there's an autofocus camera mentioned that's looking straight down at the device screen and capturing the video input that way. Then there's a USB cable, on-the-go USB cable, and of course the power supply, just to make sure that it has its electricity juice going. The Valet link hardware stack seems a little bit more complicated, but the main distinction is the number 2 HDMI capture card that replaces the video functionality of the physical autofocus camera that the vision model requires. There are a bunch of adapters that help you pretty much treat your phone and as a mini personal computer. There is a power blocker dongle that makes sure that you keep your power sources separate and make sure to share only the data streams flowing in both directions. And there is a Y splitter adapter cable that helps us act as a fake mouse, keyboard, or stylus, any other USB peripheral. I'm providing links at the bottom to the specification documents on the Tapster website if you would want to look and read up on it on your own time a little later. All right. Are we ready to move on to the last hardware slide? I didn't include it in the main stack just because it's something that focuses particularly on hardware button automation. This helps a lot in device provisioning context that we'll mention later. You can control power, volume up and down, and all of that runs on Dynamixo Protocol 2.0 connected with GPIO pins. On the roadmap right now is support for this push button module, PBM, um, to build APIs on the HTTP level so that it all integrates with the existing software and hardware modules. I mentioned device provisioning context only because I have watched a few presentations by Mr. Huggins on Valet before and collected all the feedback from the Q&A sections. And the repetitive theme seems to be, again, like sort of this lack of understanding of what these robots are for, like what they do. And I categorized the context of where you would apply it into two main classes. One is device provisioning context, and the other one is test and test automation context. What is device provisioning? Basically dealing with physical smartphones or tablets. Whenever you get a new device, out of factory or refurbished, you would need to get it set up. You'll need to press a bunch of physical buttons. Plus, if any of you have dealt with Androids, you'll need to enable ADB features to get going with any sort of even like manual programmatic automation or the actual scripted mobile automation. ADB will need to be there turned on, and without manually doing it or having a robot pretend to be a manual tester and do it, there is no third option. And that's why I decided to throw it in here to make sure that you understand that you think like the world is all in front of you and there are 50 options to do that same thing. When you drill down to it, some very basic manual motions that we do as testers with our fingertips and our eyes are irreplaceable with software, but are replaceable with the virtual robots. So you would need to decide if you're dealing with like 50 tablets, 30 smartphones in your lab, whether you're hiring and rehiring a manual team over and over, or you slow down, check yourself and maybe think about getting a virtual robot. So it gives you you can automate out of the box or get your device ready for automation without root access to the device or turning on ADB on Android devices. There is a little disclaimer on iOS is that iOS is so tricky that you can't avoid but manually having to set up the accessibility features in iPhone and in iPhone settings, and only then proceed with this robotic automation. But Apple is Apple. I haven't seen any single Apple related scenario where automation did not cause a little bit of a headache. I'm sort of used to it. Take it or leave it. But other than that, that makes it a true quote unquote plug and play technology where you can just take your smartphone, tablet, plug it into Valet Vision or Valet Link rig based on your phone model and get going. So the second context that I wanted to bring up, besides device provisioning, because I've noticed many testers like me are not very familiar with the physical device provisioning aspect unless they've actually uh, lived and breathed that mobile dev type of environment. So what's closer to most is the actual testing and test automation context. Right. And I've shown you a video from Tapster at the beginning. There are plenty of edge cases where you may need this robotic assistance. Point of sales automation, whether you need to swipe a card or at a kiosk or whatnot. Various car infotainment system, basically anything IoT can be automated with this. And where this could be also useful is in some security testing. For example, digital rights management protected videos. Like if you have like Prime Video or Netflix running on your smartphone screen, um, you may not be able to even read off the screen via automation due to security reasons. So in that case, that's where something like Valet Vision with the autofocus camera would be useful, where it would watch the screen from the outside. And as long as you know the approximate coordinates of the element that you would want to click on, for example, there's a security pop-up, you can just with the help of the vision and approximate coordinates, tap that and or dismiss or accept that alert, even in a banking app. Um, uh, or like I said, digital right protected videos. Netflix is playing. They have all the right to have their security reasons, but as Mr. Huggins mentioned himself, there is a constant battle between automation and security. It's sort of like bots fighting bots, and we have to find our place somewhere in between there. And so we do. Anyways, the in so that's how like video capture, besides the typical like screenshots or videos that we attach to like bug reports as testers. Um, Capturing video with computer vision that way, either through HDMI or autofocus camera, would be applicable. Let's All right. I think I may have mentioned most of this, of where the Valet Link or Valet Vision may be applicable. Here's a real example for the Vision hardware model, where, as I mentioned, you might get a security pop-up or alert, right, that might not appear or read through HDMI due to operating system level restrictions. But you can still click or tap that element if you've got the coordinates. Valet will give you that full visual access with computer vision, right? This may be beneficial where you may have heard from other technologies using AI, ML, and whatnot, taking making snapshots. Snapshot, quote unquote, is used left and right these days when AI services market themselves. Um, so just a second. So using snapshot technology at the very beginning, there was a big architectural diagram, which you can view in detail a little later, but that helps to sort of negate the problems when you don't have access to a DOM tree. If you've ever tried to automate like Unity games or anything like that, there isn't a DOM there. Like you won't see all of those HTML elements and whatnot. So those are scenarios where this is useful, or well, scenarios where accessibility layers through that UI structure are not visible, or if you don't have any test IDs or anything like that. So that will help you with all sorts of USB peripherals, hardware integrations, and secure environments locally or remotely. A bit of a repetition that this technology does not necessarily compete with anything. It rather complements the existing tools such as Appium, Selenium, and other automation tools. And it handles a lot of the untestable scenarios, those that only an actual manual tester can do, not the automatable, scriptable scenarios. A lot of edge cases that you may need the robotic hardware for to automate. In short, if Appium can't click it or Selenium doesn't see it, Valet probably can. All right, so this is a bit of sort of let's root into the security part of automation with Valet. In medical domains or fiscal domains such as banking apps and whatnot, as I mentioned before, you may have some sorts of screen elements or actions that are not visible through automation tools, but can only be accessed through a camera or HDMI. Those are still automatable. And this Valet solution in those cases is actually the preferred solution because, as mentioned, as long as you can look at the screen, capture that video or snapshot, and know the coordinates of the element that you need to tap, you are good to go. Let's move on. Pardon. Let's move on to the network part. So I've covered as much as I could the software chunk of the presentation, the hardware part of it, and the network. Now, the network part is now being introduced. The If any of you have heard of anything like Tailscale or WireGuard, it's a sort of a local secure VPN. The concept here is almost identical. You get secure password-based authentication using encrypted access over the network. Then virtual network communication is supported remotely or locally, all through Raspberry Pi OS. And uh, as I mentioned, it's like a mobile Tailscale for mobile or a WireGuard, where in short, it's sort of your own virtual private network for your own QA team or lab. Valet network at scale. What decentralized has to do with it? The thing is that to make it big and to spread, Jason Huggins decided to take sort of a novel route, but also following somewhat a beaten path. So following some of the solutions that he has used and has experienced before. First of all, Valet network is a network of real devices, not simulators or emulators, in real environments. You could be a solo device owner. You may have a drawer full of janky old phones that you aren't using, and those could be pulled out and made use of. You could earn some real Bitcoin and get paid fast by running automated tests through Valet. The network is built on Nostr for test job discovery, Lightning Bitcoin Network for instant payments, and Raspberry Pi for execution. We'll cover Nostr a little later. A lot of these words sound new and unfamiliar. And to make it all work, it runs either Appium, Selenium, computer vision libraries, and other character recognition libraries via USB HID. We had a slide on that called USB Gadget Protocol that makes faking of all of those interactions possible. And we have HDMI screen mirroring or autofocus camera video input stream in the case of the Valet Vision. The beauty of it, in the spirit of Mr. Huggins, is it's open source. Uh, it's flexible, affordable, and peer powered. Okay. So how would a job submission or work on Valet network? I'll break it down into three short steps. Basically, you could submit jobs via Nostr. Nostr, and we'll cover it later, but I think it's worth explaining now, is a social network, a decentralized social network. Many of you know the centralized ones, such as Twitter or X. And some of you may have noticed a grand shift from those networks like X towards decentralized ones like Blue Sky or Mastodon. Nostr is the same decentralized kind of network as Blue Sky or Mastodon. Um, it makes it super globalizable, let's put it this way, but also we can, that's what makes the payment to user or quick payment to user possible without cloud vendor lock-in, the keyword. So basically, you can orchestrate that in the CI/CD pipeline, submit jobs via with a Docker file, accompany it with your JavaScript or Python script, Python automation script, or you can write your code in any preferred language that supports the HTTP JSON client server architecture. You would sort of prepay your job, and we'll talk about what that job may be in sats or satoshis. You would broadcast to the Nostr relays, Nostr being that social network, and we'll see why that social network makes it possible at all. Then Raspberry Pi nodes run tests in Docker, and this is made possible with the USB HID inputs for simulating the USB peripherals. And we get the HDMI video capture, or in the Valet link case, and autofocus camera-based video capture with a camera in the Valet Vision case. Results delivered, we get logs, all the artifacts, videos, collected screenshots, uploaded to remote or local file server or CI server. Device reputation is updated, such as any health checks, statuses, if there's been any updates to device availability, locality, reliability, resilience, and so on. All of that is kept track of. And when you need it, the device are rebooted, restarted, and wiped off, reset for the new set of automation. Sats or satoshis are sent directly to the device owner. Once again, you don't have to deal with large cloud contracts to get any fiscals going at all in this case. I won't read out this entire slide, but I do want to inform you a bit more about Nostr. As I mentioned, it's a decentralized social network akin to Blue Sky or Mastodon. It's beautiful, just like any social network. We're all social creatures for day to day, socializing, messaging, and whatnot, for us humans to talk to each other. What's even more beautiful is what Nostr has going on under the hood. And that is what's called DVMs, or data vending machines. And that type of technology makes it possible not only for us humans to talk to each other, message each other, and whatnot, but to machines talk to each other as well. So under the hood, through data vending machines, you can have machines talking to machines. This sounded novel to me, but it wasn't novel to someone of Mr. Huggins's experience, since he's already tried this approach and it worked. While he was at Sauce Labs, he adopted a Jabber, or more correctly, an XMPP protocol to get that going as well. So this idea actually works. It's for those uninformed, it sounds radical, but for someone who's done it, obviously not. And the beautiful thing about Nostr DVMs, or data vending machines, that under the hood, there is nothing new or nothing radical at all. All we have is JSON data packets going back and forth over WebSockets, and that JSON packet and the JSON body may include parameters like what your test job is, what your target device is, what your test steps are, and so on. Let's take a look at what that may look like. In JSON in a second. But the okay. Okay, yes, I'm wrapping up. Maybe 5 minutes. Yeah, okay. So let me skip the data vending machines. The main I've explained it as much as I could on the previous slide. Mostly it makes decentralized global network possible, and instant payoffs to the device owners uh, are transacted through the Bitcoin Lightning Network. The proof of concept is this little screenshot made by Mr. Huggins. Basically, you send a particular job or a test job to an AI bot via this Nostr DVM UI shown. And in this case, Jason just asked for like a picture or an image of a robot. But in testing, you could say, hey, test this iOS model such and such, run those test steps somewhere in Zimbabwe or Bangalore or Taiwan. And moving on, I wish I could have more time, but from that previous proof of concept, that snapshot, the use case or the actual real world user scenario may look like this. You would send a test request with your own specified requirements, OS versions, subversions. You may ask an iPhone from your Android to test load times and performance of your software somewhere in South Africa, all through just very basic JSON packets. And you would prepay 70 Satoshis to get that done, which is about 5 cents USD via Lightning Bitcoin network, and get paid for renting out your phone if you choose to go that way. This is mainly a summary of what we've shown before. There are no contracts. You can avoid cloud lock-ins, decentralized. There is better device coverage because of the real hardware, no virtual devices. And this is for devs, testers, device owners, or lab owners, if you choose to run your tests cheaper and earn some Bitcoin from idle phones. Providing the link to get started today, and a QR code for convenience. As mentioned before, here it's all open source. The developer tools and community oriented. The core server and the Python client are available in public repositories on GitHub. It's DIY friendly, basically PyKVM over mobile. If any of you have encountered Tiny Pilot or PyKVM before, this is basically the same thing, only adopted for smartphones. All right, demo time, but before we get there, there will be a lot. The demo itself is really short. It's like 1 minute, but there will be a lot of stuff flying on the screen. So I sort of want to give you a quick precursor of what you will be seeing on that screen. So top left is an actual view of a physical device, of a physical iPhone. This is not a simulator. On the bottom left, the actual script that would be run, Python script that would be running and driving the whole thing. On the top right, we have a remote desktop that basically show us the web server that runs on the Raspberry Pi computer. And in the yellowish bounding box there we'll be seeing log files for flying from that web server. Then in the purplish box, at the end of once the test is over, we'll click through the snapshot images that were taken along the test and see what those are. Right. The actual test is adding 12 plus 22 in a native calculator app, verifying that it equals 34. All of that is, there are a bunch of test assertions along the way, including some OCR assertions at the end. So all of that computer vision, all of that snapshot technology is working along the way to make sure that those assertions pass. And we know that 34 equals 34. The inside joke there being 34 is Selenium's element number. Per Jason Huggins himself. Okay, another little precursor to the demo. At the end of the demo, we'll open the snapshots that were taken along the way. And we'll see three types of images. The top right from the real device is the actual template that the computer vision is looking for. And once to match up to, once the matches are found, those sharp high contrast green lines are drawn every time the match pops up. And a little grayscale image on the side that is just simplified to make it easier for computer vision libraries. All right, and not to scare you with those bright green lines, the analogy that Jason Huggins draws to those is basically that computer vision eye is something that the head-up display you see in the Terminator visions, the Termavision HUD. So that's sort of what it is doing under the hood, that computer vision part of it. All right, demo. Real device, script, remote web server running on Raspberry Pi, Raspberry web server web server logs showing in the background there. Snapshots taken as images. Now we are taking a look at these images. 34 equals 34, tests pass. We see these bright high contrast lines. This the computer vision thing that's imitating the Terminator vision. All right. And I think that's it. Yes. Woo! Let me just pause this for a second. And all right, I think we are more or less ready to basically move on to the Q&A section. And I do want to check if we have any Tapster representatives online, Megan or Jason. No. All right, that's fine. So any questions? We sort of, it was intense and it went fast. Hmm? I'm looking forward to using it. So to be frank, no, I expected to have it by now. But due to the logistics, Mr. Huggins is actually arriving here on June 5th for the conference, for the InnovateQA conference. And we are just, like 2 weeks away. It made no sense. So if it worked out differently, like I would have had it. I expected to have it. But due to logistics, it makes at the point no sense to bring it into Seattle. Yes? Well, Jason is working hard to actually present the actual thing. I believe his favorite style of presentation is show and tell. So we'll leave the privilege to the man himself. And I think he is looking forward to pulling it out of the bag and showing it to the audience. So I thought I would partake, but frankly, I feel like it's his own privilege and his own thing since it's his creation. My role here is mostly as quote unquote proxy to deliver more knowledge and information about this new technology to the public. Because once again, I've noticed that even Appium or Selenium users don't find this technology quite approachable. So we are trying to make it as approachable and as understandable as possible. And yes, long story short, to get back to that answer, I haven't used it, but I wish I had. I thought by now I would have it in my hands, but I'll have to tolerate for 2 more weeks to take a look and touch this particular Valet robot. Although I did visit Tapster Robotics office a couple years ago, and I saw all the previous versions that preceded Valet. Those were, I think, the latest physical robot with the mechanical arms and end effectors was Tapster 3 or Tapster 3 Pro. And after that, the shift has happened towards the virtualized robots using computer vision instead of the mechanical parts. All right. Anything else? Anybody else? Or should we wrap up? Yes, so the Tapster itself has certain terms and conditions that any user would sign. And it also includes provision of any repairs or fixes if there are any troubles with the actual rig. So if you go to the tapster.io website, you can contact Jason Huggins directly. All the information there, I believe they provide a quite expedient feedback if anything goes wrong. Your concern is quite understandable because when you start scaling, 20 is not 2 anymore and 200 is not 20. And every extra zero adds 10 times more headache than the previous. Right, right. Y- y- Yes, yes. Well, similar question could be asked to anyone who's ever walked into a server room, right? Like, how do you maintain or manage a server room? Keep it clean, keep it not, cool, literally, air ventilated and all that stuff. Hmm. Right, right. So the question is, oh, yeah. All right. Well, I am, I'll be frank, as I mentioned, I'm more like a proxy to deliver the message. I have not serviced the actual physical rigs or repaired them. I believe Mr. Huggins would have much clearer answers to that. And as I mentioned, there are, as with any proper business, there are certain contracts and terms and conditions signed in terms of servicing and making sure that your rig is up and running. And I cannot speak for Jason Huggins or on his behalf in this regard, but as a person subjectively, I would imagine that he wouldn't leave you hanging with a broken piece or a broken unit. He is very eloquent, obviously very intelligent, and his office is, from what I understand, his customers are superbly satisfied with his rigs and his services. Yes, but this is good to know, because actually I recently sort of had a quick conversation with him about the repairs, the servicing part. We just didn't have time to dig into it into detail. Yes, but that is a great question, which reminds me of revisiting it and clarifying it even more. Thank you so much for your time and taking, the time of day to come and visit this presentation. Hopefully you learned something new. Are there